Good evening, good morning, and good afternoon to all the time zones that are joining in. I think we are covering almost entire globe right now. It's pretty late. It's approximately 7 in the evening in India. But yeah, the content has been so refreshing that, it was pretty enlightening, and I'm really excited to present the fraud risk management to all you people here for the increment 11 and 12. Okay. The journey so far has been that in the P9, the fraud risk management was selected as the work stream to review and classify the typologies to determine which of these strategically fit into the Mojaloop. So the key things that were identified there was the development of the strategic assessment framework, a detailed classification of the risk typologies already identified, a detailed cross-reference between the risk typologies and the data dictionary that was already developed there. So in P10, we had the fraud risk management, and the objectives for the P11 and was identified and they were prioritized. Then in P12, P11, the key increments that came in here, there was the identify the typologies that were visible at the hub and that can be monitored by the hub. And then after that, we identified the additional typologies that were related, which was specific to the hub, which means that once the hub is coming into the picture, what are the additional risks going to be exposed to, and the fraud exposures that can come out of that, they were identified up. The scope was to identify that. And then there was considered the feasibility of an open source software fraud risk management solution. As a result, we got 39 new typologies, they were identified, and these typologies are core fraud risk that a hub faces when, which has to be mitigated at the hub level. And the responsibility of mitigation of that will solely lie with the hub, not with the operator there. Uh, you know, we will be presenting it into three parts. So we will have Justice and Greg. They will be coming in to present. Justice will present the fraud risk management proof of concept. And Greg will be presenting the fraud risk management open source software architecture. Okay. I start with saying that, the compliance is the difference between attaining and retaining a commercial growth. Yes, you can easily attain a good commercial growth, high figures of the commercial growth. But if in case the compliance part is missing, that growth will not be retained. Either the fraudster will come and cut short your growth, or the regulator will come and levy a heavy penalty on you that will actually cut the commercial growth short for you. So it's very important for the DFSPs to ensure that the compliance is there so that they can retain the speed of the commercial. So the fraud management is always two steps behind as well. That is my experience in the last 15 years in the fintech industry, that the fraud management and the compliances are given the last preference. Initially, the entire focus is on getting the commercial growth. So the fraud management is always catching up with the commercial growth, and you're always two steps behind. So which is not a very good thing. But I'm very happy that, the Mojaloop community has taken an initiative to make sure that we are not behind as a community, the fraud risk management, and we have the tools and the trades and the necessary expertise to ensure that the risks are mitigated even before the commercial growth starts. So the new typologies that were identified can be classified into the four domains. The first domain is the forex risk. As we are aware that there are multi-parties involved, multi-currencies getting involved, and there will be cross-border, the money transfer will start to happen, and it is happening in Mawali and in some of these other deployments that are coming up. So the forex risk is one of the risks which the hub would be taking in, which has to be mitigated and made sure we don't have exposure toward the forex side. Then the risk of running the hub is our cluster of the risk or the typologies identified fall under running a hub, which means anybody who is running a hub, they are knowingly or unknowingly taking the risk of running a hub, and those typologies are triggered for running a hub. That includes the aggregators. Then we have the internal fraud. So the biggest threat to any organization comes from its internal employees. The bomb does not explode because what happened outside. It explodes for what happened inside the bomb, the reaction that happened in. So the biggest risk to any organization comes from the internal fraud itself, and it has a great power to destroy the reputation and have huge losses to the people. So internal fraud has to be made. We need to make sure that we identify and mitigate the internal frauds. Then comes the settlement risk. So some of the risks identified are in the domain of the settlement risks. So we have in total 39 new typologies which encompass these areas. So how did we do it? So first of all, what we did is we picked up the 5 pillars, rather 4 pillars of the mobile money, which is equivalent to the ETOM processes in the GSM domain. So what we did is we looked at the key processes, that is the mobile money creation. How is mobile money getting created? What are the subcomponents of mobile money creation and how that is coming in? Then based on that, we identified what is going to be the role of the hub in creation of the mobile money. And then we identified the risks that were related to the mobile money creation, which are inherent to the hub. Those were noted down. The second process that we looked at was the mobile money movement. So how the mobile money would be moving, which all type of transactions the hub would be handling in, and what is going to be the fundamental flow of the e-money that was identified. Then we looked at the sub processes under this, and all those sub processes were actually in fact deducted into the risk, and those risks were actually related, they eventually lead to these typologies here. Then we looked at the liquidation of the money, which means that if in case the fraud happened, how the money would be liquidated, or what would be the role of the hub in case of the liquidation of the money. So similar things, we looked at the processes and all the typologies related to that, and then identified each and every risk related to the liquidation of the money. Then again, the integrations make one of the biggest component of any hub in. So we looked at how these are getting integrated, what components are getting integrated, and what are the risks of integration that we are going to take as a hub or as a DFSP. Those were looked in, and the typologies were deducted in. Then we also looked at the syndicate frauds, because syndicate frauds means that it can lead to any of the components which overlay these 4 pillars of the mobile money. Okay, APRICOT recap. You know, the APRICOT approach that was identified here. So just very quickly taking you through that. How does it, what is APRICOT model and how does it work in here? So A is for approach, which defines the process and the behavioral attributes that are utilized as part of the typologies. The examples is the unauthorized access or the suspected transactions, the products and services that define whether the typology is limited to specific products or services. Examples, the current mobile money accounts or the loans. Regulatory impact that defines whether the typology is a result of circumvention of the regulatory thresholds or the controls. Examples is going to be the limit breach, the daily, weekly, or the monthly limits that are being specified by the regulator. Are those being breached? Or there is a regional regulatory differences that happen, and somebody is able to utilize the difference in the in the regulations in one country to another country while sending the money. Involved parties, it defines the actors or the participants that are involved in the typology. The example is the end users. Is it the customer or is it the agent? The channels is what is the channel that is being used, which interacts with the typology or with the DFSPs. The example is the agent network. Is it a digital? Is it online? Which channel is being used to perpetrate the fraud? Organization scope defines the range and visibility of the typology within the ecosystem. The example is the DFSP only. Is it pair to the hub or hub to the pair? The transactions are, the transaction is defines the transactional attributes that are utilized to perform the typology. Example is the cash payment, the offshore payees, or the P2P or A2P. Now let's review one of these typologies here. In the fraud, if you look at the anatomy of the fraud, everybody, the fraudsters, they bite before they chew. Okay. So in order to commit a fraud, they need to have some information to start the fraud. So this actually not only related to the fraud, but also stealing of the information in a structured way. Now, with the hyperconnectivity with Mojaloop, one DFSP is connected to another, which is connected to the bank, which means now from a single place, you can get information from all the people in here. So the typology one actually relates to one of the syndicates. It keeps snooping to the customer's information of all the DFSPs to get the customer data that would be used as a prerequisite for the fraud or the social engineering. So how this is being triggered is they will buy the SIM card for one DFSP. They will initiate a transaction which is at a quote level. This will go to the Mojaloop. In the Mojaloop, the Pathfinder will orchestrate to find out the name of the person and where this transaction is supposed to go. It will find out what are the interchange charges or the charges that is being levied by the other parties. Will pick up all this information, bring it back to the person who has requested to send the money there, requested for the code. When he receives the code, he get all this information. But in addition to that, he gets one information that is very important for him, that is the name of the customer. Now, this fraudster or the rogue agent, he has the information, which is a NSISD number or the bank account number or any other identifier, and you also get the name of the person in here. So if you do that multiple times, you have a repository of a lot of customers that is being generated, and you have the name, you have the NSSD number, and this is starting point how they will start to commit the fraud on a mass level. But one of the key things here is they might decline the transaction, at the court level. Another orchestration of this typology, which is another typology, is that they might decide to send a very small amount of money to the other party to showcase that this is a normal transaction that goes through. So in this case, in the first case, the customer is not aware that his information is being snooped by somebody. Without him knowing, his information has already gone to the other party, and the database is being collected. And I strongly believe that this should be monitored at the hub level, because now with the hub you can easily do it across all the operators, and if in case everybody is connected, now the information of one operator can be snooped by another operator or by the syndicates. So this should be monitored at the hub level. If you apply the APRICOT model to it, the approach is the suspected transactions. The products and services is send money or interoperable transactions. Regulatory impact is going to be the trail of the failed transactions from the single source or the agent. The involved parties are going to be the individual users or the agents or the DFSPs themselves. The channels is they can use any channel to do it, which is the USSD or the web channel. The organization scope is this transaction can happen both on us as well as through the switch to the other DFSPs. The transaction is the remittance, the multiple transactions of the same page identify. Now let's look at the second typology, that is the review of that a rogue agent. Before that, let me take you on the agent model here. The aggregator is the person who is providing the infrastructure services to some of the DFSPs or to the banks, and they are the one who are integrating directly to the Mojaloop or to the central switch in here. So what is happening is the banks are connected to these aggregators via their own mechanism. And then what they do is they take the transaction of the bank and then they aggregate it and take it to another switch, or they take it to the DFSPs directly. And then in the end, they do the settlement with these operators. And this is how the one-to-one mapping of the, or let's call it in the Eastern Africa region, the aggregator origin have started, because they wanted to be interoperable without the Mojaloop. But in case of Mojaloop, how that risk will actually materialize, some of you might be able to link it back to the famous Uganda fraud that happened a couple of days ago. So yes, this typology somehow relate to that Uganda fraud as well. And the risk in the Mojaloop would be that if in case a rogue agent is able to get into the aggregator's system, so now here he has the digital signatures of the rogue of the aggregator here. So if the aggregator has the weak IT systems or the weak IT processes in here, the rogue agent is able to get in. Now the moment you get in, what they can do is now they have inherent usage of the JSON signatures that are being used to do the transactions, which is verified by the Mojaloop. So when they send or pump in the transactions from DFSP A to DFSP 1, they will use the signatures of this aggregator and the transaction will be received at the Mojaloop. Now this Mojaloop, when they will validate, is it a valid operator or not? They will say, yes, it's a valid operator because it is JSON signed. And then the payment would be made to the DFSP1. Now DFSP1, the customer will, those customers where the money is being sent, they will start to, do the withdrawal there. In this case, what is happening is that this aggregator is taking an inherent risk, but ultimately the visibility of it would be completely available on the switch only. So the switch is only going to be able to see all these transactions what are going through. DFSP1, or if the fraudsters are smart, they will spread their transaction to DFSP 1, 2, and 3. They will only see these transactions that, okay, these transactions are coming to us to multiple people. But the DFSP A, B, and C, they will not be able to see that my customers are doing the transaction or it is a fake transaction. They will have no visibility at all. But the risk of the settlement will lie with the DFSP A, B, and C, whereas the beneficiary would be DFSP 1, 2, and 3. So nobody will end up mitigating this risk. So I think this is where the Mojaloop has to make sure that we have the central monitoring and we are able to find out if in case such things happen and those are being monitored in here. Let's apply the APRICOT model to it. The approach is the suspected transactions. These are all the transactions that can happen. It can happen via layering. It can happen via direct transaction as well as P2P transactions. The products is the send money or interoperable transactions. Regulatory impact is the trail of the transaction coming from the single source or the agent. Involved party are the individual user, institutional users, agents, and the DFSPs. The channel is going to be the USSD or the web, because USSD would be used to withdraw the money, or the web would be used to inject the transaction into the aggregator. Organization scope is both on us and off us, which means some of the transactions can be monitored better by the DFSPs, but major transaction would be better monitored at the switch level itself. The transactions involved here would be the remittances, P2P or B2P. Asante sana from my side.
Thank you, Sudhir.
Karibu. Sudhir, quickly, there was a comment and thread in the chat here, and Justice makes the point that we'll have to build up a perspective over time for a lot of these in order for them to be seen as illegitimate, since any of the things that you describe have legitimate reasons. That is, I entered a payment and I inverted 2 of the digits in the phone number and the name comes back wrong. I might do that twice because I'm fat fingered. And finally, I get it right. So the point is simple repetition of the same new payment that I've never made before to a person I've never made, which goes to cancellation or decline, is not necessarily by itself fraudulent. It's just I'm not very good at using the phone, especially when I'm using a triple tap USSD phone. I'm likely to get that wrong. However, if this continues to happen, or it happens repeatedly beyond what I'm calling a velocity limit, the DFSP themselves can see this happen immediately. They can see, they don't even need the hub's opinion about this because they're aware of the declination as it occurs. It times out on their own system, and they can see the structuring going on. The problem then is that we would ask 100 DFSPs to all do the same thing and I'll get it right. And so those two things together, Justice's point that you might want to take a time-based perspective on this to assess the scoring risk of a particular kind of endpoint-based declination like this, where you're declining transactions for the purposes of the metadata collection. But that you could also look at the velocity limits themselves and the proper application of that being done better at the center. But again, I think you would want to make sure that that's a scoring-based system that's returned to the prepare side or the fulfill side for their own use. We wouldn't want to be trying to block these transactions at the center, in my opinion. I think, you know, it's about visibility for scoring. It's not so much about intervention.
And Miller, when you're saying velocity, you're talking about velocity of attempts, velocity of transactions only. You're not talking about you know, volume or anything else. It's just the number of attempts exceeded a certain number of attempts. We're going to stop. We're going to institute a timeout. You know, you're thinking something along those lines, and then a
Correct.
dynamic
because
risk rule.
Yeah, for this particular typology, no one's going to pretend to send $10,000 because I might accept it. But you're going to send me 10 shillings and you're going to eat the fee and say that, well, I came out, you know, if you actually accept this, fine, I paid 10 shillings. But in the event that you didn't, you never had more than the fee at risk, you know, for that money, because you're paying you're ultimately, you're going to end up paying yourself. What you're trying to do is figure out who it is that you can spoof transactions to collect these monies, because you're going to then turn around and add this on to your social engineering attack where the money is going to be higher, but the velocity is much lower. And at that point, yeah, the expectation is your arbitrage is high velocity, low value payments on one side versus the low velocity, high value payments on the extraction side. And the presumption is that a properly modeled fraud would render more money out than was used to set the thing up on the front side. So yeah, I think it's the speed of transactions coming from a single endpoint to random participants for which there's no record of them ever having sent money before, and with lots of declinations. That if I were to say, if you asked me to write the rule for it, it would be something like that. But I suspect careful study of this may turn out a rule that's even more finely nuanced than that for each of these. Anyway, that was my thought, just having seen that.
I think very fair point that, you know, yes, you know, quite a lot of these information are going to be the false positive, but again, we need to protect the customer, you know, information in here. But if in case, you know, over a period of time, we can identify that the based on the patterns that based on certain algorithms, because these processes, they behave in a particular way. You know, if we look at the locations and we look at the channels and the how, you know, because if you use a SymBoxer here, right, the IMI is going to be the same. So there are some complex analysis if we perform, we can easily identify with the help of some algorithms that these transactions are genuinely failed. Sorry, excuse me. These are genuinely failed transactions as compared to these are the ones that are being used for snooping. Okay, and then again, there is other traits as well involved in here. So there's only not one trait that defines that this is a fraud. There's an additional information and there's additional, you know, controls, or let's say that threads that, you know, we earlier discussed, that those, if you combine this, only then this is coming out to be a, you know, pure fraud. So one typology will never lead to one fraud. If we look at the Uganda fraud here, and when I was, you know, trying to understand that, we have 4 typologies that were triggered to commit one fraud. So yes, there's not one typology that will always give you one type of fraud. There are multiple typologies that combine together to trigger a fraud.